Swayam Prabha. Digital India. Educated India.
Hello student. So, we will continue the module 9 biological treatment that we are discussing about composting. So, today's lecture is on compost quality. So, in the previous lecture I was talking about for sustainability of compost plant is very important to look upon the compost quality because the product has to be marketable. And the many times this kind of discussion you can see that whether this compost can be replaced by chemical fertilizer. Is it possible? Especially in the agriculture sector. I personally believe that this compost, if it is in the good quality, when I say good quality means it contain good nutrients, not harmful effects into that final product, but if you just compare with the nutrient values is not comparable with the chemical fertilizers. Like take the example of urea where 30 to 40% nitrogen is available, but in the compost maximum amount of nitrogen could be possible, maybe we can reach up to 2%, 2.5% if you are using for earthworms or vermicomposting process, but by normal composting process like conventional composting is very difficult to reach up to even 1% nitrogen also. In vessel composting also in last lecture I discussed where we can reach up to 2%, 2.5%, but is not comparable with the chemical fertilizer. So, when these questions will come up whether we can replace the chemical fertilizer with the compost, so I do not think so is possible to replace of that, replace to the complete replacement of chemical fertilizer, but it is possible that the farmers can use this compost in different percentage, maybe 15%, 20% replacement could be possible, or mix of chemical fertilizer along with the compost could also possible, and especially for the flower production, especially for the vegetable production, I think these compost are highly beneficial compared to the chemical fertilizer. Maybe the yield from the chemical fertilizer will be very high, but the kind of vegetable will get produced out of that, it could consist of a lot of chemicals into the final product, but if you use the very good quality compost in the especially for the vegetable growth or vegetable production, I think the quality is also very good, but yield that won't be very high. But if you are using for the continuously this kind of compost maybe for 4 year, 5 year or 6 year, then the yield also will be very high, because your soil also will be very good soil could be possible after 4 to 5 year. And if you are continuously using the chemical fertilizer, your soil quality also will be very quality will be reduced, and not only the carbon content but even the nutrient content will be also very low into by utilization of more amount of chemical fertilizer. But again I think this discussion is on the comparison of chemical fertilizer with the compost, but even for the centralized composting or decentralized composting facility, the operation maintenance cost is very high. So, in that case we required the good quality of product which could be marketable, at least it could sell by 5 rupees or 10 rupees at least in 1 kg, then the sustainability could be possible for such kind of composting plants. So, that is why it is very important to talk about the compost quality. So, when you say the compost quality, what do you mean by this? Compost quality can be evaluated through laboratory analysis. There are a lot of parameters need to be analyzed in the laboratory, and also need to be described the how best it can be beneficial for the soil by addition of nutrients, and also how the physical property of the soil could be increase or could be benefited for the soil by addition of compost, that also need to be discussed very well. So, when I say the compost quality, the first point will come into your mind, that is it should be good physical and chemical characteristics, means your physical property and chemical property should be very good, that the first point will come up. And second point, it also contains the humic substances. Now, see these humic substances, this you won't get it into the chemical fertilizer, but if you are using the compost, obviously also need see that how much amount of humic substances could be possible into the compost material. And also the final product should be well matured. So, see again this maturity or stability is one of the very important parameter of the compost, because if it is not matured enough, so it will create problem into the soil. Suppose take one example like the complete degradation or complete matured compost is not available, it is possible that it will utilize the soil nitrogen for the whatever the microbes available into the compost, it will take it out the nitrogen. So, obviously it is a problematic one. So, your compost should be highly matured enough, and also I think this is the positive factors which required for the any kind of compost is getting produced, but also required low amount of trace elements. What do you mean by trace elements? I think this is a very the concentration is very low, that is a metal concentration. From where this metal will come up, because in the organic material huge amount of metals are available, especially some of the weeds like water hyacinth, even paper mill waste material, these kind of organic material will have large amount of metals, like take example of sewage sludge also is contain large amount of metal content, but the amount is trace, but is a highly problematic for the not only for the soil but also for the plant. So, that is why the trace element should be low into the final product, and also no foreign matters. Foreign matters means I think like which we have saw in the last lecture, if you are going for the non segregated waste material into the windrow composting facility, and after filtering there are a lot of foreign matters could be possible to add into the final product. Also no pathogenic organism, that is also very important. That is why we talked last I think 3-4 lectures I was talking about thermophilic composting, so that not pathogens could not be available, should not be available into the compost, and these all pathogens are available into the almost all kind of organic matter, which is including kitchen waste. Obviously, in sewage sludge the pathogens will be there, but other industrial organic waste also the pathogens will be available, and no organic contaminants or inorganic contaminants should not be there. So, now the first is that good physical and chemical characteristics. So, how to what are the parameter has to be analyzed to know that good physical and chemical characteristics. So, there are 3 major properties or characteristics has to be analyzed. First is the physical parameter, which is including bulk density, the porosity, void ratio, water holding capacity. See now the bulk density, porosity, void ratio, this is very important physical characteristic or physical properties of the compost, because we required to add such kind of material into the soil which will increase the porosity, increase the void ratio. Because of that the water holding capacity will be very high, so that the more amount of water will be available for the plant growth into that particular soil by addition of compost, and bulk density is also very important. If you add the low density material like compost into the soil, because soil is a high density material. So, by addition of compost the density also will be low. So, that this is very important for the growth of the plant. Next is the chemical parameter like total gender nitrogen. This is very important. Ammonia content, total and available phosphorus, micronutrients. This is another nutrients. So, normally when you say the compost, normally these nutrients will come up N, P and K. So, this is what is available in the chemical fertilizer also, NPK based chemical fertilizer like the urea is a nitrogen based, phosphate is a phosphorus based, and especially the NPK fertilizer where nitrogen, phosphorus and potassium will be available, that is also. And apart from that there will be other micronutrients is highly beneficial for the soil and plants, that is sodium, calcium, magnesium, and also some the trace amount of iron is also very important for the soil and plant growth. And along with that the biological parameter like soluble BOD and COD, BOD 5 and COD, this also very important one where we can know that how much amount of organic matters are available into the final product. This is also the similar way we can analyze as we were analyzing for the sewage, only we have to leach out the water from the compost, and the same sample can be analyzed for soluble BOD 5 and COD also. Similarly, the coliform, this is what the fecal coliform, to know that how much is the pathogenic microorganisms are available, this also we can easily do. And finally, the stability, this stability or maturity can be analyzed by two major parameters, one is the oxygen uptake rate and CO2 evaluation rate. Now, this is very important to know that normally in India nobody discuss much about the stability of compost or maturity of compost. So, here the idea of the analyzing of this parameter to know that how much amount of oxygen is getting uptake by the compost, means whatever the air you are adding and air addition in the in-vessel composting, but by simply in the rotary drum composting the rotation, by the rotation how much amount of oxygen is getting uptake by the material, and because of that how much amount of oxygen is getting evaluated from that particular mass, that need to be know that, because in the final matured material there won't be a much amount of organic matter, means there won't be much amount of microorganism. So, your oxygen uptake rate also will be low, and similarly your carbon dioxide evaluation rate also will be very low. So, this is all parameters are very important to know that the physical and chemical characteristics of the final product. Now, these are physical effects of composting on soil structure. So, compost particle is lighter and finer than a soil particle. On mixing with the soil, the compost particle decreases the bulk density as mass per unit volume reduces owing the lighter compost material. Compost particle being finer increase the adsorption area, which is in turn increase the water holding capacity, void ratio and porosity. So, this is what in the bulk material there will not be a much voids into the mass or into the soil, but by addition of compost you will see here lot of voids has been created because of addition of lighter material like compost. So, because of that there will be increase in water holding capacity, void ratio and porosity of the particular soil. Now, the chemical parameters one by one will go. So, while in the composting process, I think before looking onto the final product also need to be analyzed during composting how these chemical parameters are changing with the composting period. So, the pH is important because the precipitation of essential nutrients out of solution may occur at high pH, and a pH between 5.5 to 8 is optimal for compost microorganism. So, obviously, 6 to 7.5 is very good for the bacteria and 5.5 to 8 for the fungus. So, your raw material also need to be have the proper neutral pH for the degradation process. And if you see the changes into the pH, initially it will lower down because of organic acid production, and after that it will increase because of ammonia release, and finally ammonia will be volatile into the mass, so that we will get more amount of total nitrogen into the final product. So, because of that pH will be neutral. So, normally we called as in composting process itself as a buffering capacity. So, it will maintain the pH into the compost mass. So, for vegetation and plant growth in the agriculture, pH 6 to 8 is very good for the vegetable growth and for soil microorganism. So, matured compost generally has a pH of between 6 to 8. As compost decay, it goes through a cycle of varying pH levels. It usually begins quite acidic, but over time the composting material become more neutral. If the soil in your yard is slightly alkaline or acidic, you can try to modify your compost pH level to counterbalance and amend your soil. This is also possible, and you see that by addition of more amount of chemical fertilizers, soil become acidic, and because of acidity of soil, there are lot of nutrients is getting leached out in the form of runoff. So, because of that soil quality will also will be reduced. So, to maintain the pH or proper pH into the soil, if you add such kind of alkaline pH compost where pH is around 7.5 to 8, these kind of compost will able to modify the pH of the soil also, and it will come up or stable at neutral pH. Okay. So, this is way we can analyze the pH. So, this is the neutral pH required for the finished compost. Now, you see here at the different pH, I think the quality of the products also. See at the neutral pH, your nitrogen will be very high, phosphorus will be very high, potassium. See here, this is the way where all the nutrients is very good. So, pH from 6 to 7.5 or up to 8 is very good to maintain the nutrient quality of the product. But similarly, in the same, see at the lower pH your iron will be more, manganese will be more, boron, copper and zinc, this is all metal at acidic pH will be in the large concentration. So, if you maintain the proper pH, even your trace elements also will be in the low concentration. So, if you see the stoichiometry of the composting process, the degradation of organic waste neglecting the minor contribution of degradation of nitrogen and sulfur to the mass loss can be approached stoichiometry. So, this is one author has been given this particular equation. This is what the chemical formula of organic material, and finally, this is what the compost chemical formula is able to produce out of that. So, this CaHbOc represent the initial mole composition of the waste, and this is one is the mole composition of the stabilized waste. But again I think by stoichiometry we can will know about how much amount of carbon, hydrogen, oxygen could be possible to produce in the final product. But still I think there are a lot of minor contribution should be neglected into this stoichiometry. So, another parameter that electrical conductivity. So, electrical conductivity refers to a mineral salts or amount of mineral ions in the solution of the compost and water. So, this is very important. The concentration of final electrical conductivity also depends upon the conductivity of soil. So, while in the composting process, so this will be the flow of the electrical conductivity. So, initially it will increase by the release of ions, and finally, these all ions will be precipitate, and the volatilization of ammonium ion, it will reduce the electrical conductivity. On this electrical conductivity is very important to know the phytotoxicity of the plants. So, if more amount of salts, mineral salts are available into the final product, is not good for the plant growth. Okay, it will be a phytotoxic, that particular product. So, EC should be required is around, I think less than the less will be more beneficial, it should be 2 to 3 Siemens per meter, I think is good for the final product compost. Next parameter is the organic matter. So, obviously organic matter are the source of nitrogen and carbon to the microorganism. So, this is the flow. So, initially it will be reduced more, and finally the reduction will be slower down. So, this is the thermophilic temperature, thermophilic condition, this is in the maturation condition. So, the first the microbial assimilation period. So, this is the first thermophilic, that is from the easily biodegradable organic matter, and finally, this reduced because of degradation of lignin or hemicellulose, which is very difficult and where maximum the fungus will work for this degradation. And finally, stable organic fraction, which is including newly formed micromolecules and humic substances. Okay. So, in a particular time period, this organic matter will not reduce. Next is the nitrogen dynamic. This is very important to know that, because there are different kind of nitrogens or changes could be possible. So, the microorganism utilize nitrogen for synthesizing and building cell structure. So, this is the particular graph, you can see that this graph is between time of composting period versus nitrogen. So, it will have 4 different nitrogens. So, is there total nitrogen, this is organic nitrogen, this is nitrate nitrogen, and this is ammonical nitrogen, okay, and which is required to be less than 0.4%. That percentage should not be high, because this ammonia is not good for the soil, also is not good for the soil microbes, not good for the plant growth also. And why these changes could be possible? Because the total nitrogen is increasing because of net loss of dry mass or water loss, and finally, maybe some of the author studies that there could be a nitrogen fixing bacteria which will increase the total nitrogen, but is not completely true, but I think some of the literature shows that is possible. Now, this organic nitrogen also will increase because of strong degradation of mineralizations to ammonia, and initially there will be a loss of ammonia, and once the thermophilic phase will be get over, in the maturation there will be a nitrification, then the nitrate will get start to grow, and obviously see the plant are required inorganic form of nutrients. So, this is what the plants will be utilize nitrate and ammonia, okay, for synthesis of the microbial consortia. So, your nitrate concentration should be more and your ammonium concentration will be low in the final product. Okay. Now, next is the stability. So, this stability normally analyzed by CO2 evaluation rate and oxygen uptake rate. So, during various metabolic activity like respiration, carbon is used as a source of energy during composting process, which leads to decline in organic carbon and release CO2, and oxygen uptake rate is directly manifestation of oxygen consumption by the microbial population and hence microbial activity. So, this is what the flow of carbon dioxide, the reduction of carbon dioxide evaluation, and this is for oxygen uptake rate. Obviously, your oxygen uptake rate will be more compared to the carbon dioxide evaluation rate. Okay. Now, the metals in compost. Okay, this is one of the most important discussion when you discuss the compost quality, because these metals are inorganic in nature. Okay, because in the entire composting process your only organics will get degrade, your inorganic concentration will be the same. So, because of that, because entire your mass is getting reduced, so whatever amount of inorganic materials are there, especially metals, in the final product you will get large amount of that particular metal. That is why need to be analyze the metal concentration into the substrate or in the feed material, how much amount of metals are available. If the metals are more, obviously in the final product also metals will be more, because finally mass is reducing. So, this is inorganic one, there will not be any degradation. So, final product also you will have more amount of metal concentration in the final product. So, like in the example like water hyacinth, which is very well known for the metal absorption from the water for their growth. So, if you produce compost out of that, this compost will contain large amount of metals. Similarly, with the sewage sludge, which contain large amount of metals, in the final product also you will get large amount of metals. And what will be the problem with these metals? There will be a direct problem with in the soil, also there will be a indirect problem for the crop, there could be problem for water pollution and also possible indirectly. So, directly for the soil health, it will reduce the soil fertility, it will alter the microbial population and processes, and it will modify carbon mineralization in the soil, and also the nitrogen transformation also will be changed. Similarly, in the indirect problem for the plant health, could be induced oxidative damage, could modification of signaling and biosynthetic pathway, abnormal reproductive response, and also anomalous genetic behavior could be possible into the plants. And by this also you can see that the direct impact and indirect impact could be possible for the plant. So, because if that particular soil after addition of compost, if that soil is having more amount of metals, obviously these metals will be absorbed through the root of the plant, and finally from the root it will go to the stem to the leaves and fruit. So, the more amount of metals will be available not only in the leaves, but also the fruit also you will have more amount of metals. This is not good for the human health. Now, the pathogens in the compost. So, the presence of coliform bacteria is often used as an indicator for overall sanitary quality of the compost. So, Salmonella species were regarded as a problem of the hygienic quality, and the major factor contributing to the reduction of both total and fecal coliform is the attainment of thermophilic temperature during the composting process, which I discussed in the first lecture of the compost also, how this thermophilic temperature or how these pathogens will be inactive by achieving thermophilic temperature into the compost mass. So, now normally that recommended fecal coliform and fecal streptococci. So, the source of fecal coliform is a human, and fecal streptococci the source is animal. So, in this case now if you are using the sewage sludge, so in the sewage sludge more amount of fecal coliform could be possible, and if you are using cow dung or any animal dung for the compost production, your streptococci could be possible. So, as such there is no standardization of the pathogenic bacteria, but there are a number of studies has been done in the academic institutes, and they suggested that the fecal coliform should not be more than 100 or 500 and should not be more than 5000 this quantity in the final product. But this quantity also will not be possible if you are able to achieve temperature of 60 degree or 65 degree centigrade into the compost mass. So, the pathogens will not be possible to survive at this high temperature. One more important point for the compost quality is a phytotoxicity. One phytotoxicity we saw with the electrical conductivity, it should not be more than 2 to 3 decasiemens per meter, that is based on the mineral material. Now, this phytotoxicity is because of a lot of chemicals could be possible, especially the allolo chemicals could be possible into the organic matter, and especially when we are doing the composting of weed, especially terrestrial weed or any water weed, there is always possibilities of toxic allolo chemicals could be possible, and this toxicity also will be also come up through the metal also. If metal is more, it will be a toxic to the plants. So, that phytotoxicity or toxicity has to be analyzed for the final product. I took the example of this Mecania micrantha. This is a well known weed, soil weed. Normally we find in the at the tea plantation. So, if you produce the compost through even for the in-vessel composting by rotary drum composting, and where we are able to achieve 60 degree temperature, and if you do the toxicity test, you see the when you 100% compost we are using, and if you compare with the control, the growth is very poor. You see here control without compost is the growth is good, but by addition of compost growth is low. That is why the toxicity is very important. Even though the nutrient quality is more, toxicity needs to be studied before application into the soil. So, this is another study of phytotoxicity. The simple test we can do it in the laboratory by Vigna Reddy and LM Sepa. By that way we can study. You see here the growth of the mung seeds by addition of 100% and by control and 25% the growth is more. This is for the Vigna radiata or mung beans, and this is for Allium cepa. You see here the growth. So, here the 100% growth is low compared to 25%, see here. So, this is control, this is control, this is 25%. So, this is highly beneficial, 25% addition for the growth of particular plants. But suppose whatever the final product will come up, if it is toxic also, and if it is contain more amount of metal, then what could be the solution? So, what is the solution if compost made is not good and metal content is high? Means like in the especially this problem will come up into the centralized composting facility, where they are not able to produce very good quality of compost. So, the nitrogen content is 0.5% or less than 1%, other nutrients also will not be possible. So, why not some corporations add chemical fertilizers in order to increase the quality of compost. So, it is possible that by addition of some chemical fertilizer in the compost, the nutrient quality can be increased, but is not suggestible, but I think many corporations are doing that way. I do not have much literature onto that. Even the private operators also, for increasing of the nutrient quality of the compost, they are adding chemical fertilizer. This is not good anyway by addition of chemical fertilizer in the compost. I think you see that how these microbes will get affected by addition of chemical fertilizer, but for increase of nutrient quality, that people are doing that. And to lower down the metal concentration, by addition of some chelating agent like lime, zeolite, biochar could be possible to add into the composting process. So, what will be the effect of addition of lime or zeolite? Now, initially because the lot of nutrients are getting leached out, okay, because contain more amount of metal. So, by addition of zeolite or lime, the slight pH will increase, of the compost. So, slight means the pH could be up to 8. So, because of that and these chemicals like lime and zeolite is able to adsorb onto the nutrients. Nutrients will be adsorbed onto the these kind of material, these kind of chemicals. So, the entire nutrients will be possible to into the compost mass, it will not be leached out. And if you add the biochar also, I think here you can see that by simple control you can see the leaf of the lettuce biomass, but addition of 40% biochar, you see the lettuce how it has been grown. So, this is also good idea. I think this I accepted that if the more quantity of metals is there in the final product by addition of very small quantity of lime, maybe 2%, 3%, or in the similar way zeolite also if you are able to add or even biochar addition also could improve the quality of your compost, especially it can reduce the solubility of metals. Now, there are some status I found for national compost guidelines, like how the guidelines have been prepared in the various country like Australia, Belgium, Canada, Denmark, France, Greece. Okay. So, like Greece, basic solid waste rules are available, but no official compost standards. Like for other like Hungary, new compost quality association they prepared. Like Luxembourg, some compost plants follow German quality assurance system. Netherlands, fully established quality assurance and certificate system. Like in Norway, the compost quality studies underway, criteria proposed for 3 quality classes. So, the many country they talked about type 1, type 2, type 3 quality compost or class 1, class 2, class 3. So, it is a simple understanding, type 1 or class 1 means highly matured, class 2 means is a okay, like medium quality or medium maturity compost. There is a class B or type 2, and type 3 or class C is considered immatured compost, and even the purposes are different where to add these kind of compost. Like class 1 or type 1 can be utilized for the agriculture purpose, but type 3 or class C should not be used for the agriculture purpose, could be possible to addition of soil improvement in other area, because it is not well matured compost or not good quality compost. So, should not be used for in the agriculture area. That kind of guidelines has prepared by various country. So, like in the UK, the proposed quality standard by private composting associations, and USA compost regulated under biosolids or fertilizer rule, and different rules in the different states. Now, I think some of the country also come up with status of compost quality seal. So, whatever product you can put particular seal onto the product. So, now for the Australia, there were 3 classes of compost 1, 2, 3, and you see the particular seal they prepared. Like in the Belgium agriculture agency, 2 classes different. Similarly, with the Germany federal bio-waste decree in 1998, and they have private compost association also, and they have particular quality seal, they put it onto the product. Similarly, Italy, Luxembourg, Netherlands. So, Netherlands like waste law 2 classes like clean compost, very clean compost. So, you can put particular seal onto the product. Similarly, USA also have one particular seal is available. This is some special standardization for heavy metal content in MSW compost versus source separated compost in relation to the German standards. So, it is a mixed MSW compost. These are the major important metals could be possible to available into the metal like lead, copper, zinc, cadmium, chromium, nickel, is possible, and they produce different kind of standard like German standards. What is the concentration milligram per kg of compost. Similarly, bio waste compost, what should be the maximum concentration of metal? Metal is only allowable in the final product. If the metal concentration is more, so this kind of product won't be acceptable in the agriculture area. This is another one like recommended limits for heavy metals, use rates of compost for vegetable with typical soil level. This is specially for the vegetables. So, this is a German standards. So, this was for the based on the different feed or different substrate or different material. This is specially for the utilization purpose, for the vegetation purposes. These are the metal standards are given, and this is typically for the soil. So, once you add into the soil, the metal concentration should not be more than this percentage. This is the permissible metal limits in US and UK. So, Europe have different concentration, and USA have different concentration. Is again depend upon the quality of soil and the quality of product or quality of vegetation into that particular soil. Now, this is the NPK and calcium and phosphorus essential nutrient, their standards. So, here you can see the test parameters like salt, available nitrogen, phosphate, potassium, maturity, organic matter, pH, foreign matter. So, this is a comparison between German, Austrian and USA. So, here in the Germany they use this maturity, the particular Dewar stability test, and in USA they studied the Solvita maturity index, which I had shown one graph for stability of Solvita maturation index. Okay. If you are interested to know more onto that, you can read some research paper, because there are a lot of issues which we can't discuss more into these classes. Because if anyone is interested, you can read more onto the maturity, how to analyze the maturity, and to know more about the maturity indexes. This is the electrical conductivity of compost is explained. This is the rate of sensitive plant and rate for tolerance plant. Okay. So, this unit is liter per meter square of that particular soil area, and these standards are available. Now, plant growth performance standards, like this is specially based on the phytotoxicity based. So, plant growth test like in the German 25 to 50% compost in standard soil media, barely seed or cress seeds must pass greater than 90% in barley test. So, they have different kind of standards is available, like for plant use compost must be tested for the actual use recommended on the bag, like in Austrian recommended test in actual media, in Australian to use categories with specific limit for agriculture and gardening purpose. Okay. So, these are few plant growth based performance standards. Now, again for the model compost specification according to US EPA for soil amendment. So, this is specially for the standards provided by US EPA, means US Environmental Protection Agency, which explained about the pH should be neutral 5 to 8.5. Soluble salt concentration should be maximum 10, that is electrical conductivity decisiemens per meter. In one of the slide I showed 2 to 3, but in the US EPA they suggested up to maximum 10. Moisture content 30 to 60%, because we required moisture to be available into the final product to survival of those microorganisms. The organic matter is also required, the particle size So, here they suggested 98% pass through 3/4 inch screen or smaller. Stability, so they also explained about carbon dioxide evolution rate should be less than 8 milligram carbon dioxide production per gram of organic matter per day. The maturity also required minimum 80%. Similarly, the biological parameter like fecal coliform, particular they have standardization is required, and also salmonella standards is also available. Now, this is the Canadian Compost Council. They come up with Canadian Council Compost standards. They come up with class 1 and class 2. So, for product safety and exposure, the product must be safe for sale and or use. When assessing the safety of product, the exposure must also be considered. If there is no exposure, there can be no risk. These guidelines attempt to categorize the concept that exposure in an integral part of the risk by establishing different grades of material like category A unrestricted, category B restricted on the basis of safety. So, the compost product guidelines they prepared by unrestricted use like compost that can be used in any application such as agriculture land, residential garden, horticulture operation, some nursery industries or other businesses, that is category A. So, category A criteria for trace elements are achievable using the best source separated MSW feedstock or municipal biosolids or pulp and paper biosolids or manure. So, this is the category 1, and category B is very restricted for particular purpose, that quality is also not that good. Now, the standard for stability, I think there is as such there is no standardization, but I think you can find this particular source. They come up with the oxygen uptake rate should in between 0.5 to 1.5 milligram per gram of volatile solids per day, and CO2 evolution rate also should be in between 2 to 8 milligram per gram Vs per day. So, here the minimum is 0.5 means is a highly matured compost, highly stabilized compost, and if it is 8 or 1.5 means is not that very good matured compost, or you can say immatured compost. Now, is another germination standards. So, seed germination, which I showed few slides of mung beans and Vignaretia, where germination index we can analyze, or seed germination we can do. So, if there is 90% of seed germination means very matured, and less than 80% consider as a immatured compost. So, likewise here we can see. Now, come to the Indian standards. So, Central Pollution Control Board in 2006 they come up with heavy metal standards on milligram per gram dry basis of the compost. So, various metals they consider, and we have in India normally these fertilizer control order are available for the compost. Now, in 2016 in the solid waste manual these standards are given. Now, if you want to market your compost in India, you have to follow the FCO standards, quality standards. So, which is including the moisture content, pH, electrical conductivity, total nitrogen, phosphorus, potassium, carbon to nitrogen ratio, and few metals. So, this suggested only 0.5% of nitrogen could be possible to sell into the market, or is a marketable. That is why see even the standard is very low, 0.5% nitrogen in India, and if you see for vermicomposting there they mentioned the total nitrogen maximum 1%. So, mean then again I think I am saying that if this kind of compost which is good under the FCO standards, but can't replace the chemical fertilizer by having. And these I think why this kind of standard has been come up as per my understanding, because centralized composting facility is not able to produce that kind of good quality compost. So, that is why the nitrogen concentration also mentioned very low. That is why I think if you want to purchase any compost from in the market, you will not receive or you will not get it very good quality compost. And I think now because there is a e-marketing, e-commerce has come up now. So, even in the Amazon also you can find number of companies are selling the compost, and the cost is very high. That cost goes to sometimes 400 rupees per kg. But if you see the quality of such compost is not good. The nitrogen is very poor. Why I am saying nitrogen? Because nitrogen is the major nutrient in the final product, and even the metal standards also no, I think these kind of company they also never mention how much is the metal concentration in the final product. Okay. Now, finally, the why to use the organic fertilizer? Because already in India under Swachh Bharat mission, the many states came forward and trying to become organic in nature, and you know that Sikkim is become the first state of India which completely converted into the organic agriculture farming they started. So, 100% organic farming they are doing it. So, to go for organic farming obviously will be required, apart from biofertilizer will be required large amount of compost and good quality compost which can be utilized for the agriculture area. So, there are a lot of advantages of organic fertilizers for not only for soil nutrition, but also for the plant growth. So, obviously, the compost enhance the soil and protect watershed if you are utilizing into the soil, and also we can create lot of jobs in the composting facility, because if you are going for incineration or landfilling, like incineration, there you do not require the manpower to run that particular technologies. Even for the landfilling will be required less number of manpower, but for the compost manufacturing you will be required lot of manpowers, lot of people will be required, whether you go for centralizing facility or decentralized facility. Now, you can ask me, sir, you are saying the operation cost in the decentralized composting is not much, but see this manpower cost in India is not that very high. So, we can engage many people, even we can engage females, we can give more jobs into such kind of facility, because the task is very easy to do. Simple filtration task or addition of different kind of mixes of that particular substrate is required into that particular decentralized facility. So, obviously, is good for the market also. So, finally, the quality is very important. If any compost plant want to be a sustainable, so is obvious it required a very good quality product has to be produced, then only I think such kind of plants could survive for minimum of 15 years or 20 years. So, finally, the final slide, the compost quality, good or bad. So, which I explained lot of parameters has to be evaluated in the laboratory, and number of facilities are required to analyze the nitrogen, phosphorus, nutrient quality, metal quality, toxicity of compost, stability of compost. But by simple layman person, how they can know that good quality and bad quality. So, the bad compost means the foul smell, the smell will be foul, indicate presence of toxic compound, mostly ammonia smell, and if you squeeze the compost, squeeze in the hand, the water will come out. So, means that compost is not matured compost, is not prepared compost, That is the simple understanding. So, you visit any compost facility, take the smell, and if you get good smell, this good smell is of particular bacteria, actinomycetes. So, you know that actinomycetes production in the just before to the maturation stage, means your thermophilic condition is lower downing. So, that smell just like soil smell, I think that smell has to be come out in the final as in final product, and also the water should not be leached out from the when you are squeezing the compost. When we can say is a good compost is a proper texture, color, no foul smell, there should not be any smell or ammonia, appropriate moisture content, it should not be sticky. Okay. When you squeeze into the hand, the color dark brown color indicates mature and stable compost, it should be free from insects and nematodes. So, if you find some kind of mites in the final product or some nematodes will be there, means I think still the maturation has not been over, the compost has not been prepared yet. By that way, simple layman understanding also we can come to know without doing the chemical experiments. So, thank you.